Numerous reports indicate that manufacturing has emerged as the favorite target of ransomware groups and hackers. In response, a new report from Industrial Media discusses the evolution of industrial cybersecurity, its current state, and the tactics hackers are using, including phishing schemes, malware, and ransomware attacks. It also details solutions in arming manufacturers with the knowledge and resources needed to win more fights on this highly complex and ultra-competitive battlefield. Download the industrial sector's new battlefield by going to manufacturing.net/cyber. Hi, I'm Jeff Ranke, Editorial Director of Manufacturing.net and Manufacturing Business Technology. Welcome to Security Breach. The ongoing theme in industrial cybersecurity centers on two competing dynamics. First, we have the desire to expand our implementation of automation and Industry 4.0 technologies with the goal of using more and faster connections, along with the decision-making data each generates to improve the efficiency and quality of production. However, these goals now need to be counterbalanced against the heightened risks that all these connections spawn and the doors they can open for hackers looking to shut down, extort, or steal data from manufacturers. There has perhaps never been a more important movement impacting the future of manufacturing than the need to improve OT cybersecurity, and in many cases this has to start with a more complex but potentially vulnerable machinery, devices, networks, and software being implemented to meet next-generation goals and stay competitive on a global scale. Here to discuss some of the building blocks on which these security measures will be built is Joe Saunders. He's the CEO and founder of RunSafe Security, a leading provider of cyber hardening solutions for embedded systems and devices. Joe, thanks so much for joining us today and welcome to Security Breach. A place that we like to start here, especially when we start talking about embedded systems and the ICS, is the different vulnerabilities that pop up. And everybody has a different core specialty, and we'll get to some of the things that RunSafe does a little bit later. But when you look at the industrial landscape right now, whether it's embedded software or different things within the industrial control system, what are some of the big vulnerabilities that you're seeing right now?
Well, I think the major category of vulnerabilities includes memory-based vulnerabilities, and memory safety has become a big issue. Not only has the NSA issued guidance on solving for memory safety and memory-based vulnerabilities in November of 2022, but it's also a situation that's been included in the National Cybersecurity Strategy in 2023, and is one of the core tenets of Secure by Design offered by CISA. And so the vulnerabilities that are memory-based vulnerabilities are weaknesses that MITRE considers the greatest software danger in software today, because it has the most known exploits against and also has the most numerous vulnerabilities in general for compiled code, which is the lion's share of software that's deployed in critical infrastructure.
Now, you have a kind of a unique focus. Correct me if I'm wrong. You guys work with a lot of defense companies, a lot of aerospace folks, and also on the automotive side. Is there some things that are unique to those sectors that you're seeing, from whether it's the embedded software? I know SBOMs have become a huge topic right now. Things that you're seeing that are maybe more start there, but we could definitely get into other industries as well.
One of the issues, I think, when you look at the industrial use cases, aerospace, defense, energy, industrial automation, as you say, transportation, including automotive. If you've seen one software build tool chain, that's what you've seen, one software build tool chain. It's a highly fragmented market. There's different operating systems in which, people are building their applications on. And what's unique about that is those are often real-time operating systems. They're not general purpose operating systems. And that adds a layer of complexity. But also then there's the emergence of embedded Linux and other build tools that help people to really build new versions of their products on open source software. So what I see in general in the market is both a shift away from proprietary operating systems and the adoption of embedded Linux operating systems, but also, given the lifespan of products, we're talking devices that might get installed in infrastructure that lasts 10, 20, 30 years. And so the ability to support, I'll call it legacy code, but code that's been around a long time also becomes a major factor. So you can't just discard old code and replace it every year or two when you're talking operational technology, manufacturing systems, industrial automation facilities, let alone automotive platforms like cars and the like.
Absolutely. Let's dig in a little bit there, talking about some of that embedded software because it's more and more prominent in more devices, more industrial machinery, especially as we incorporate greater levels of automation. What is the rub there? Because on one hand, you're appreciative of all that inherent operational functionality that comes with that embedded software, but then as you just alluded to, there's the updating that becomes more difficult, the patching that becomes more difficult. What are we seeing there in terms of progress and sort of walking that line between embracing it but also accepting some of the vulnerabilities or issues that it can create?
I think you have to look at it from an economics perspective initially, just to understand the dynamic. If you look at operators of infrastructure, let's say, energy facility or, a utility or a water utility or some other industrial automation facility in general, they are making capital outlays that are going to last that long lifespan, the 10, 20, 30 years that I talked about. So trying to get people who have already invested in their infrastructure to replace technology is hard. One of those drivers is, of course, security. But if there's other means to extend the life of that capital investment and bring security to those devices, I think a lot of organizations would, if there's not another compelling reason, a new feature, new innovation that's going to drive them to upgrade to new software. And certainly, smart devices and connected devices are some of those reasons. But that's part of the equation, I guess, is they've already made capital outlays. They may have some security concerns, and then they're thinking about, okay, what is the other value add that I need to invest in to justify an additional capital outlay today or a new economic model?
I'm with you, Joe. I can already see and hear our audience going, yeah, but man, then I got to dig into this again. And I thought I already solved this problem. And now it's like creating more layers of things that I need to verify and check and dig into. And we're in a manufacturing facility here. We don't have time to stop and slow down and do all this. What have you seen in terms of best practices in getting the industrial sector to this, just embrace this as this is a new normal. This is just part of doing business now on a day-to-day basis.
By that, I mean, I think you're talking about security.
Right.
And with that, of course, there has to be, a good value proposition for, protecting the assets that they have in their operations today. And so, can it be disruptive? Yes. However, if there are ways to minimize that disruption and still provide a level of protection, what we have seen is, when you do make updates to your software, and I get there's, you want to do that on a limited basis, and you want to keep your operations going. When you do, what you want to do is address securities at the class level, not the individual vulnerability level. And if you do that, then you can smooth out the patching process, smooth out the updates, and minimize that disruption. Because the other side of that equation is, yes, there can be a consequence if there is, in fact, a cyber attack. And so as systems become connected, if you're trying to get data from, the industrial automation floor, if you will, and get that operational technology data to understand what's really going on, well, that does create some attack vectors, and it does put infrastructure at risk. And what we've seen is nation states are targeting critical infrastructure. They're targeting, energy grid. They're targeting water utilities. They're targeting all sorts of, other compiled code that's embedded across critical infrastructure. So the threat is also rising, just as the complexity of disruption is rising. And so the unifying thing is security, as well as other innovation for people to make change.
I want to dig into something you just said there about making some of these, not changes, but doing some of these security checks, if you will, at the class level. Because I think we get into, with cybersecurity especially, everybody has a little bit different definition, a little bit variation on how they go about things. And I like the fact that we're not going vulnerability by vulnerability, because that can be so daunting. People want to stick their head in the sand and just not deal with it. So could you dig into a little bit more of that strategy in terms of the level at looking at security and making sure everything is where it needs to be?
The conventional wisdom around security is, when I find a vulnerability, I fix it and patch it. And that is the overused metaphor is whack-a-mole, because it's a never-ending game, right? And you just keep trying to chase that, and that's exhausting. That is an exhausting process, because You're reacting to the next great, vulnerability. You have timelines to meet and everything else, and it consumes scarce resources also. So if you think about it from economics perspective, if you have an approach that doesn't require a whack-a-mole approach, and maybe it's more to the tune of immunizing technology from cyber attack for an entire class of vulnerabilities, then you can see you're getting much more scale out of your security program, addressing all the vulnerabilities of a certain type. And you do that by preventing the attack against those vulnerabilities instead of trying to defend and instead of trying to patch and fix each individual vulnerability. So in the case of RunSafe, what we've done in that realm, I guess, if you want to think about it that way, is we've made it so even if an attacker gets onto a target, you can't compromise that software because they can't find the vulnerability in the first place. And if you address vulnerabilities that way by, the equivalent of moving target defense, then the exploits fail. And so if you can do that for a large class of vulnerabilities, and again, in critical infrastructure, it's a majority of vulnerabilities. It can be anywhere from 40 to 70% of the vulnerabilities in embedded systems are memory-based vulnerabilities. And if you take all of those off the table, then the good news is those same operators who are worried about patching software, they're really focused on the other 30, 40% that are not mitigated. And that's a much improved economic model for folks from a cyber perspective.
Boy, that's a great point. I mean, ROI is so important in terms of getting buy-in throughout the enterprise, throughout the organization, because we see a lot of, for lack of a better term, sort of cyber champions just coming from the plant floor and up through the enterprise, but it gets to that C level, and if they can't see a direct correlation to profitability, it sometimes gets kicked back. But to kind of lay it out the way you just explained it there in terms of what this can do for this type of strategy, it makes a lot of economic sense, and it's going to have greater benefits from an operational perspective as well.
Operators, one of the new, programs that CISA is promoting is secure by demand, and arming best practices for operators to ask for security protections from their suppliers. And if the operators can lean on suppliers to harden the software that gets deployed in their infrastructure, then that even makes that case even better because it's included in the products that they're buying. And that starts to improve that overall process between supplier and operator, as well as the individual operations just to update vulnerabilities. And so if you're able to generate a software bill of materials and share which of the vulnerabilities are already mitigated, then that improves communications, but also gives the operator the confidence that you're on top of the problem. So I think that relationship between product manufacturer supplier is key. I think CISA is right to promote secure by demand, really ask operators for their suppliers to do more, and that becomes a shared experience. We've seen that in cloud deployments where it's a shared model. It's a shared model between the cloud provider and the solution provider who's deploying software in the cloud. There's a shared security model there. And part of that responsibility is the operator, in that case, AWS or Azure or Google Cloud or Oracle Cloud, in any of their customers. There's a shared security model. And I think that also has to get adopted across critical infrastructure between operator and product manufacturer. And secure by design is a good way for people to communicate. And in that process, they can ask about memory-based vulnerabilities, and they can look at software bill of materials and identify vulnerabilities that could be addressed in the way that I was talking about earlier, that asymmetric change or asymmetric shift in eliminating the exploitation of an entire class of vulnerabilities.
No, I agree with you 100% in terms of that being a joint effort or a partnership between the buyer, i.e. the manufacturer, and the supplier of those tools. As a manufacturer, okay, that's what primarily our audience is going to be, the one making that purchase. What are some things that they can do to make sure they're fulfilling their role? They're doing their part in that partnership to make sure that everything, whether it's the cloud, like you mentioned, there's tons of challenges there, or the whole secure by design dynamic as we incorporate more of these Industry 4.0 technologies. What can we be sure to make sure the manufacturers are doing their part?
I think the manufacturers in general should have a risk management framework and a way to assess and quantify the risk that they're exposed to. And that includes identifying all the assets, within their infrastructure, in their manufacturing process, in their operational technology infrastructure itself, and identifying those vulnerabilities. And that's where they can ask for suppliers to provide information. They can ask them to supply a software bill of materials. They can use that software bill of materials to identify vulnerabilities or provide a solution, find a solution provider who can enable that information. And if you do that across your top 10, 20, 50 suppliers, you start to get a really good sense for where are my vulnerabilities. So if he has a risk management framework and an ability to see vulnerabilities across assets, across suppliers, then you've got a really good view and you can start to prioritize from there.
But that's a great strategy just because it seems to address a couple of other glaring weak spots at times for a lot of manufacturers, which is asset visibility, understanding what's all out there and being able to see it. I should say asset inventory, and then asset visibility. Both of those things are kind of resolved a bit with that type of approach, or at least supported better than what is in place right now for a lot of folks.
Yeah, 100%. And then also, I think part of the key is that dynamic between supplier and manufacturer. To the extent that suppliers are willing to share the software bill of materials, there may be ways for that to be shared without disclosing all the components in their software, but giving them the ability to understand and share and get visibility on vulnerabilities. And the key there, from my experience, has been if you can say, hey, here's the process we're investing in as a supplier, here's the software bill of materials that we're generating, here's all the vulnerabilities that we have identified, and look here's all the vulnerabilities that we take off the table already, and let's talk about what's left over from there, so we can work together to make sure that the manufacturer in that case is protected.
Well, and it's all part of just continuing that ongoing journey of making it as difficult as possible for the hacker, to the point where ideally they're going to at some point just give up and go on to maybe a weaker target, if you will, and it's not you. So making it as hard as possible for them. Joe, let's talk a little bit more about, you mentioned some things that RunSafe is up to. Maybe you could talk to us a little bit more about some of the stuff you're doing to help support industrial cybersecurity.
Yeah, absolutely. And so RunSafe was built on the premise to fundamentally change the economics of cyber attacks. And we were looking for an asymmetric way to protect software, and built on that premise that we talked about of, scanning, fixing, and patching is an exhaustive process and one that never ends. And so what we've done is we've eliminated the ability for an attacker, whether it's a nation state or a sophisticated attacker or someone who's renting tools from others, to administer their exploit in the first place. So even if they get on target, and one of the tenets we have as a company is, bad actors get in, they compromise software supply chain, they breach networks, insiders get into facilities. So even if they get in, even if they get on target, an exploit that they administer, a backdoor that they're trying to exploit, they can't administer and deliver that payload and exfiltrate data or hold something for ransomware, or simply disrupt operations. And so that was the whole premise of RunSafe. And the way we do that is we offer a code protection software that hardens software as it gets produced by suppliers. And with that, our customers have said, hey, manufacturers, operators of infrastructure, other folks really want visibility into what's happening. And so we invested as a company then, in addition to the code protection, we invested in the ability to generate a software bill of materials that enumerates every component in the software. And that is helpful because then you can associate all the vulnerabilities with those components and really understand not only how to help your customers, the manufacturers, but also how to understand your software supply chain and the open source software you might be using, and which ones might be putting not only your products, but your customers at risk. And so the software bill of materials creates that visibility. It identifies the vulnerabilities, helps the product manufacturer determine, how should they prioritize what they upgrade in terms of new security protections. And then that all flows through. So at the end of the day, we are a software supply chain security company. We have the RunSafe security platform that identifies risk, protects code, and monitors for software crashes deployed out in the field with a feedback loop into that risk model that we have up front. So RunSafe licenses all of our software on a subscription basis and allows our customers to, really smooth out that whole process of operations in delivering software with higher code quality.
Excellent. You mentioned SBOMs and supply chain. That's a great connection point to make there in terms of sharing a lot of that information. How have you seen that change maybe over the last couple of years, especially with more high-profile attacks, critical infrastructure, supply chains? We're seeing how a manufacturer gets hit. It doesn't just shut down their operations. It shuts down the retailers, the logistics providers, the delivery folks, and all so on and so forth. Are folks on the industrial side, are they getting better at sort of sharing the information from those SBOMs so that people can see what is and is not covered potentially and try to help each other out?
There's definitely a significant rise in the adoption of software bill of materials, in part because of past cyber attacks and the executive order that the Biden administration put out. And so, there is a growing interest in software bill of materials. There's a willingness to share now that there wasn't in the past. So, I'd say since 2010, SBOMs have been a thing that have increasingly gotten more and more interest. But in the past 3-4 years, I think we've gotten past the stage of where people are reticent to share, and they're starting to see that it's a foundation element to help improve the security posture. And so if you look at it that way, instead of, I'm exposing all my software, it's, hey, I'm communicating visibility and transparency into my code quality. And that mindset shift is starting to change. Another factor in that is that the adoption of open source software is increasing. So those who produce technology are aware that they're using open source software more and more. And what I've heard, some statistics in kind of the industrial use cases overall, if I look across industrial automation, a lot of suppliers there are getting away from proprietary real-time operating systems and shifting towards embedded Linux and other operating systems because it's easier to deploy and the overall processing power is increasing. And so with that, what that means is the rise of open source software in industrial automation or the increase is accelerating. And so I guess my point in all of that is that open source software supply chain is as much part of the supply chain in general for everybody. And with those past attacks, with the executive order, there's so much more awareness that we need to come up with solutions.
So we've got different parts of the manufacturing flow, the supply chain working together. We've got more manufacturers, distributors, logistics providers, retailers working together in this whole effort to be more secure and keep the hackers out. What about internally? Because one of the biggest silos that we see in manufacturing is we've got IT over here, we've got OT over here. They're not always real crazy about working together, but in this day and age, it's becoming more and more important to get those two in the same room. What have you seen lately in terms of those two converging and working together a little bit more, especially when we're looking at something like embedded software here?
I think if you look at like the levels of operational technology, that level 2 where you have HMI or SCADA systems or the like, those tend to be closer to IT systems, certainly more so than PLCs and what maybe a robotics device looks like on a plant floor, what have you. And so that's where there's a lot of commonality and similar language used. And so, even though those systems oftentimes are divided, some of the challenges at that level 2 are much more alike than what you see on the IT side of the house. And so I think there's a lot of sharing between there, more and more anyway. And as a result of that, and plus the HMI and the SCADA systems are large attack vectors for OT and for industrial automation. And so I think that people would, if they chatted, would find a lot in common to talk about, even if their environments are different. Right. Yeah. And so I think that's where the commonality is. PLCs are obviously specialized and do important things and whatnot, but they do operate differently than a general purpose operating system serving up an HR application in general. And so, I think the HMI and the SCADA systems are a crossover point, and these things are converging as a result of that.
Well, and it's interesting how you bring that up, and there is all those connection points, right? We're seeing more and more. You thought not to keep harping on supply chain, but we've got supply chain management software. If somebody can get in there, they can get into your ERP, they can get into all those HMIs that are on the plant floor, and once they're into the plant floor, who knows where they can go? It's all interconnected. And one of the things that I've been talking to folks a lot about lately is Do we need to take a step back on the OT environment? Are we over-connected? Have we gone too far with getting everything connected and getting all that data visible to everybody? What are your thoughts there?
If you think about, let's say you are implementing some kind of autonomous process in the industrial facility or the manufacturing plant. Let's say you're implementing that and you need data about what's operating and where the status is. Getting information off of whatever systems are operating that is very, very important. Data is the lifeblood of business operations today, and that's true in the OT world. That's true in the IT world. And I was visiting an automaker recently, and we were talking about digital twins digital twin technology is essential going forward for some of these organizations. And what fuels digital twin simulation? It's the data of real life operations. And so how can you avoid that? If you want to improve your processes, you need the data. And if I go back 30, 40, 50 years, and you're looking at an assembly line in an auto manufacturer, there were people with clipboards and pencils and stopwatches, and they're measuring steps. And that data was super helpful. Well, now we have all these sensors inside these facilities collecting data, and we're looking to improve. We're looking to save money. We're looking to improve quality. We're looking to make all sorts of other changes. Why? Because these organizations want to be more and more competitive. So I don't think it makes sense to go backwards. I think it makes sense to progress and to improve. And that modernization does include connectivity, as you say. It does produce, a large amount of data to process. And I know that makes some people uneasy, but at the same time, it's all for the right cause. It's for good intentions. And that is to improve processes, make your company more competitive and whatnot. And part of the cost of that, unfortunately, is the security concern. But should we make progress as an organization? Yes. Should we make progress as an industry? Yes. Do we need to invest in security as we modernize systems to realize these benefits? Yes. And so that's my case for it. And I would say, keep connecting, invest in security, and improve your overall processes.
No, I think it's interesting and very, very well said, what you just mentioned there. And I think what we're learning is just as products have become more customized, processes have become more customized, cybersecurity cannot just be a one-shot deal. It's going to need to be customized for everybody as well in terms of the application, who we want to see things, what types of connections we've got in place. I think each one of those need to be looked at a little bit more closely and not just take a sort of a cover-all type of approach.
It's interesting that you say that, though. And I know we're jumping gears a little bit here, but if you look at what the FAA did recently, they elevated cybersecurity for airworthiness. And the reason for that is because cybersecurity is a safety issue. The reason I bring it up here, though, is if you're looking at autonomy, you're looking at automation, safety is a major concern in facilities, and security is an aspect of safety as well. And so as we progress and have connected devices, we have to be concerned about safety and compliance towards safety. And if we do that, then we can realize the benefits of it. But safety is essential. And I know that that's what drives, a lot of concerns for folks, because one, you want to be in compliance, but two, when danger is part of the consequence and, life is on the line, then safety has to be treated as paramount.
So not to steer kind of in a negative direction here, but when we talk about cybersecurity, we have to talk a little bit about the threats that are out there too. Are there any particular types of attacks, threat groups or category of groups, if you will, that are sort of on your radar now that are causing a lot more issues or sort of elevated the whole embedded software security dynamic that we've been talking about?
I think some of the public information is readily available, that China is inside U.S. critical infrastructure in general. And what we do know is they are targeting memory-based vulnerabilities. If you think about advanced persistent threats, such as, organizations like Volt Typhoon associated with China, those are real concerns. And I think the overall MO, of organizations like that are affiliated with China in general, they are taking a long view. They're very persistent. And they are, targeting ways to disrupt things. And so, when memory-based vulnerabilities are targeted by, a well-funded adversary, there is reason for concern. And there's all the more reason to elevate your security posture in general. And I think the challenge is U.S. government trying to figure out, for example, how to encourage producers of technology in the U.S. To take that step and fend off even those threats. But I think that's a building concern that I'm very concerned about over the next several years. Do I think there's an imminent attack again coming next week? I really don't think so. But over time, there's one common denominator across all these facilities, and it's the software we use, and that's the great vulnerability as well. And so, software leads to great efficiency. You can replicate software easily, but when there's determinism and vulnerabilities in software, then attackers, well-funded attackers, can exploit that. I do think that folks should be worried about ransomware. And I do think that people should be worried about safety concerns related to vulnerabilities and what could go wrong there. So to me, those are some of the big drivers for organizations.
Absolutely. Ransomware continues to be an issue. Another type of attack that really seems to kind of bleed well into what we've been talking about here are these dwelling or live off the land types of attacks. What are you seeing there in terms of maybe improvements that manufacturers are making, or maybe some different tools out there that are strategies that have been effective in sort of warding them off or identifying them?
It's obviously very hard to identify living off the land. And that's one of the concerns. And then the attacks are fileless based attacks, which means you don't really see it coming until it's happened. And so indicators of attack are becoming more important than indicators of compromise in these scenarios. And when people are testing, will this exploit work? Then what you find is that information sharing is important. And so I would think that information sharing across, ISACs becomes very, very important. And naturally, I also think, finding ways to mitigate and I hate to go back to memory-based vulnerabilities, but that's actually what is being exploited. So if you're living off the land, leveraging tools inside the software, and you're remaining there in a persistent way, only to deliver an exploit, or a payload later, essentially someone's waiting to pounce. And you need to be able to fend that off. And these fileless attacks are memory-based vulnerabilities getting exploited. And so I think that's one of the key things people need to realize is, yes, you might be able to find some living off the land situations, but they're very good at not being found and or remaining persistent even when found.
Well, understanding how to fend them off, but also kind of reinforces the need for those response plans because you don't have a ton of time when those types of attacks occur. So it reinforces the need for those. Joe, this has been fantastic. A lot of great information. Really appreciate the time. Last thing before we kind of sign off here, we've talked a lot about a lot of challenges, about a lot of sort of the tough elements of industrial cybersecurity. So let me ask you this. When you go to bed at night, what helps you lay your head down and be at ease knowing that we're going to be okay?
I do think that the government's doing a great job. If you look at Director Wray talking to Congress, you look at Director Easterly from CISA talking to Congress, you look at the fact that the NSA issued guidance back in November of 2022, that the Office of National Cyber Director issued the National Cybersecurity Strategy. All of these things are consistent and in line. And so I feel very confident that the folks operating at the highest levels in government are very, very aware of what the dangers are. And for me, it's the real challenge is getting that message out further. And so I encourage everybody to take a look at what CISA has done with Secure by Design and Secure by Demand, and also take into consideration the executive order for software bill of materials and these other things. And so I think the government has done a great job pushing us in this direction without mandates. So it's up to industry then to come back with response, and it's good for business and it's good for national security if everyone starts to shore up defenses even more.
Thanks, Joe. And for more information on the work he and his colleagues are up to, you can check them out at runsafesecurity.com. I'd like to thank you for joining us today, and to catch up on past episodes, you can go to manufacturing.net, IEN.com, or mbtmag.com. You can also check Security Breach out wherever you get your podcasts, including Apple, Amazon, and Overcast. And if you have a cybersecurity story or topic that you'd like to have us explore on Security Breach, you can reach me at jeff@ien.com. For Joe Saunders, I'm Jeff Ranke, and this is Security Breach.